having a collective, accurate, shared mental model of a complex system is one of the most important parts of building software. One of the key focus points that I bring up with the teams I work with, and for the record, I'm mostly working with established teams in legacy, sort of large SaaS companies, in some cases startups. But one of the key focal points is how they are using these technologies, large language models, AI, etc., to augment their process. What is incentivized when you're working with AI to build software is to be very, very specific about the behaviors that you want from your system at the outset. So you might spend a lot more time writing that product requirements document, the tests that need to pass, and then letting a system execute. And you have a level of verifiability about this system if you have good tests and if you have good design documents. And I think that when you're working across teams, one of the biggest challenges is when things are changing so fast, how do you preserve the collective mental model of how the system works? And having a collective, accurate, shared mental model of a complex system is one of the most important parts of building software, of building anything complex, of engineering in general. It's sort of the reminiscent of three blind men touching an elephant or a rhinoceros. Each of them comes away with a different conclusion about the nature of the beast. It's the job of the engineer to keep their model that lives in their head reflective of the underlying reality of the thing that is in code or in the world. And that model has to be updated. And in many cases, the ability to update that model can become the bottleneck for building new things, because that requires reading. And that's not always the part that people are investing in when they're adopting AI-driven software development strategies. For example, one of the best practices that I anchor on is creating really great summaries of changes that a system has made when you are submitting those changes to be reviewed, using lots of note-taking abilities to represent the sort of process of design and what has been implemented up to a given point. I think even making these documents and these write-ups part of the code base itself is going to become a more and more common practice, such that you are keeping a natural language representation of the system going alongside the system itself, such that somebody can refer in a relatively low effort way to some explanation of what's happening, an explanation of all of the edges of the system and where things might remain open or problems that are left unsolved, without necessarily having to dig into the minute edges of that system. So I think this practice is all changing a lot. It's really interesting to see.